So Thomas, I love the content for you to like those content you post on Instagram. Love it. And
Thank you.
I think there's one of my great friend Josh, who
Yeah.
who work I think he has a mentorship with you. Am I right?
Yeah, correct. Just fan.
Yeah.
Yeah, yeah, great guy.
So
Very, very humble and knowledgeable
yeah,
as well.
yeah.
So I really like him a lot. Yeah.
Good. So for those who are interested in, well, so for those who like didn't know that much and also interested in like sports science, can you like introduce yourself for the audience?
Well, sure. First and foremost, I guess I'm a performance optimization coach. So I obviously work with the strength and conditioning part, but I also often work with the technical part. Um, I've primarily worked within athletics. I've been a high jump coach for 15 years now, working with athletes on an international level, both in terms of junior athletes and senior athletes as well. I work within a professional sport in Europe called team handball. It's definitely not big in Asia. You do have some skilled national teams, but it's primarily a large sport in Europe. It's our second largest sport here in Denmark, just after football. So I work as a strength and conditioning coach within that realm. And then I work with a professional badminton player as well. That's probably a slightly larger sport out there in Asia. I work with a player called Anders Antonsen, so he's among the best in the world. So that's really interesting challenges as well. So that's like the practical part of what I do. I also work within the academic environment. I'm part-time employed at Section for Sports Science at Aarhus University, and I mainly lecture in a subject called athletics and movement optimization. So we're basically using the principles of biomechanics and physiology to try and optimize movements within both closed skill sports and open skill sports. And last but not least, I'm a founder of a company called Occlude BFR. So I've actually specialized in producing blood flow restriction equipment for physios and professional sports clubs and hospitals. Yeah,
Nice. Love that. Love that. So, uh, the first thing I want to ask is on your Instagram is like impulse versus power. So can you like talk a little bit about like what is impulse, what is power, and how is it different, and how can we like coaches like me can like use these kind of like data?
sure. Um, if you want to start, we can start out by power. So power is a measure of rate of work or force times velocity. We can measure that either by instantaneous power or mean power, typically measured in a concentric movement. Um, Intuitively, as a coach, the ability to produce higher power values depends, it's obviously the product of force times velocity. So for us to intuitively understand it as coaches, it's basically the ability to accelerate a mass already moving at relatively high velocities, because we won't reach high power values if we have a large mass accelerated relatively slowly or not accelerated at all. Then we don't have a power. Or the opposite, having a very small mass being accelerated rather rigorously. So we need somewhat of a combination of a relatively large mass being accelerated at any time point quite rigorously. So that would give us high power values. And that is in terms of some sport specific movements. Sometimes it's a reasonable surrogate measure of our performance in sport-specific movements. But I would personally claim that a measure like impulse is significantly more interesting, because impulse is often the determinant of performance in sport-specific movements. So it could be your vertical jumping ability, your change of direction, actually also to some extent sprinting. Then we would have to relate it to time. So it would be something like rate of impulse, because we are also constrained by the time on the ground. We want to make it as brief as possible, but produce as high force as possible. And I can give you an example why I think impulse is an interesting measure. So I'm a high jumps coach, and the single most important factor for jumping high is vertical takeoff velocity. Vertical takeoff velocity, if we look aside from air resistance, that's what determines our vertical displacement of a center of mass, 100%. So if we want to jump high, we want to optimize vertical takeoff velocity. And we can measure height based on that. It's vertical takeoff velocity squared divided by 2 times gravitational acceleration. And gravitational acceleration can be slightly different depending on where you are in the world, but more or less it's always around 9.81. So we're basically dividing it with a constant. So our jump height is just dependent on vertical takeoff velocity. So to jump high, we want to maximize that. And we actually have an equation that tells us how to maximize that. And that's the impulse equation. So the impulse equation is just a derivative of Newton's second law. Force equals mass times acceleration of set mass. And the impulse equation is force times delta time, so the change in time, equals mass times delta velocity, so change in velocity. And that's actually what we want to do when we want to jump as high as possible. We want to maximize the change in velocity. So when we do that, we can actually just isolate the change in velocity. And when we do that, we have force times time divided by mass. So already there we have an explanation why high jumpers look like they do. They have a relatively small mass because you actually divide by mass. So physics are telling us how we should look like, more or less. So to optimize vertical takeoff velocity and understand it as, imagine you have a horizontal approach. And so you have a horizontal velocity vector, and you have a vertical velocity vector, and it's the vertical velocity vector we want to optimize. So typically when we get into our takeoff, we'll have a slightly negative vertical velocity. Actually, we'll be moving downwards, just typically around 0.5 or 1 meters per second. But we actually want to minimize that. So we want to make it as small as possible. And then we want to have the vertical takeoff velocity to be as high as possible. So change in velocity from getting into the takeoff, and then during takeoff, maximize the vertical takeoff velocity. So that's our task. And then already now we know that's dependent on the force, the vertical force we're able to produce, multiplied by time, divided by mass. And then what we need to acknowledge is that there's somewhat of an inverse relationship between force and time. So if we produce a lot of force, we'll have less time on the ground because force accelerates your mass upwards. So there's somewhat of an inverse relationship between those. If you're a jumper and you aren't really able to produce these very, very high amounts of force, then we need to alter your technique to increase your time. So if your average force is slightly lower than the best in the world, then we need to optimize the time factor. And we can actually alter that slightly by how we jump. That's typically the difference between power jumpers and speed jumpers as well. So in a lot of movements, I would claim impulse is really interesting. That's actually what causes how high we jump. It's the net horizontal impulse that fully determines if we are accelerating or if we're decelerating or if we're keeping a steady velocity. The same in terms of conducting a change of direction quickly. Then we have momentum moving into the change of direction. And if we're really, really skilled at producing high amounts of force, then we will reverse that momentum getting into the change of direction. So our ability to exert an impulse, at least in relatively close skilled sports, is just a key determinant. And in some movements, power could correlate to performance, but it will always be a surrogate measure somehow. So why not use the measure that actually causes movement? So I've had, it's probably a year ago, I had a small rant about why are we always looking at power, and also especially peak power, because we can easily produce very, very high power values without actually performing a movement that's on a very high level. So let's just look at what actually determines performance.
Love this. I love this. So basically what coaches like me, like practical coaches like me, when we describe power, we often like misunderstand like what is impulse and what is power. And
Yeah.
from what you were saying, that was like you just mentioned, we should more focus on impulse instead of like power.
Yeah, I mean, I definitely don't have an issue with measuring power. I just think often impulse is a better measure. And sometimes we need to relate that to time. So we need to create a large impulse relatively to time. And that's, in a practical sense, that's basically just acceleration. So change in velocity divided by time, that's acceleration.
Yeah.
And we are going to accelerate a mass very rigorously if we produce high amounts of force. So that's the key quality. We need to be able to produce as much force as possible in order to accelerate our own mass. So that's, force is truly king.
So since that, like uh should we be like kind of want to jump out the question list. Should we be more focusing on like training acceleration for like most of the sport?
Well, definitely changing deceleration and then subsequently acceleration. So that's basically what occurs in a straight shortening cycle. So our ability to decelerate something will affect our ability to build up elastic energy in our tendons. And we can actually, back to the example with the change of direction, if we have a very high level on our deceleration skills, then we can decelerate later in the movement. So that would allow us to conduct the change of direction quicker. So I would definitely focus on training both, and we do that by all stretch shortening cycle movements. Yeah.
Nice. So like you mentioned, deceleration and acceleration. So uh Is that a reason why I saw you post a lot of like eccentric work for your athlete?
Yeah, definitely. I mean, it's the same as sprinting. We're typically talking like for an acceleration phase, a steady top velocity phase, and then a deceleration phase. You want to minimize as much as possible. But actually, what occurs is uh, is accelerations going like we're accelerating and decelerating at every time point more or less, so we are never truly have a steady velocity. So we are decelerating a little bit while we are in the flight due to air resistance. We're decelerating at the first part of touchdown because we have to break the downwards momentum by gravity, caused by gravity. So we're decelerating, and then we have the propulsive phase, and then we're accelerating again. So yeah, I mean, but back to your question about me prescribing typically super maximal eccentrics for my, could be my jumpers, it could be my overhead throwers as well. So that's basically trying to, well, it's multifactorial why I do it, but one of the reasons is to improve their ability to decelerate. So, and the most specific way to do that is obviously on court. It's throwing an implement, it's jumping, and so on. But having worked with high jumpers and jumpers in general for a lot of years, I know I can't expose them to high intensity jumping more than two, maximally three times a week. So if I want to still train that ability to decelerate and then subsequently accelerate either their own mass on an implement, I need to look at something else that could be quite specific, but doesn't put a toll on the same recovery systems. So that could be super maximal eccentrics. So that's actually, I mean, it's all about reversing a momentum somehow. So when we're doing it in jumping, we have our own mass moving at a certain velocity. And we typically have, so let's say we're doing hurdle hops or other types of plyometrics, we will maximize momentum through velocity. So we can't really change our own mass in the acute situation. So we're just doing through velocity, and then we can reach really, really high peak forces that are quite difficult to reach in the weight room. But it's basically a conversion or reversal of a momentum. And it's the same in the weight room. It's the same that occurs when you're doing your squat, and also when you're doing super maximal eccentrics. You're just doing it, you're increasing mass a little bit, but you're decreasing velocity. So it's trying to give somewhat of a specific stimulus while putting a different toll on the recovery systems.
So then since you mentioned that for those like jumpers, you're gonna train them like they basically train eccentric when they're doing jump or like throwing, but you also want to like uh let them to train the same like eccentric but without like jumping. So there's coming like super maximum eccentric. But how would you schedule the jumping and like the super maximum eccentric work?
Well, I typically do that through periodization. So when I expose my jumpers to relatively high intensity plyometrics or technical training sessions, then I would try not to expose them for super maximal eccentrics in the weight room, because that'll simply be too much. So I typically alter that, modify it through periodization. So in periods where I don't expose the athletes to high intensity jumping or plyometrics or sprinting, I can allow myself to expose them to a high extent in the weight room. And I didn't mention that earlier, but a part of doing these super maximal eccentrics is also about making the muscle fascicles as injury resilient as possible. So, and super maximal eccentrics are just awesome at that. You'll have a lot of exercise-induced muscle damage at your first bout, but then you'll have the repeated bout effect. So it will, the muscle fascicles will obviously adapt and make themselves stronger to tolerate this eccentric stimulus.
Nice. So, kind of want to like go back to the first question you mentioned, like, uh, if an athlete, if a jumper wants to jump higher, they must have to like produce um amount of like a huge amount of like impulse. Am I right? Impulse, right? So,
Exactly. You're right. A maximal vertical impulse.
so
That's what we want to maximize.
yeah. So, in order to create like maximum amount of impulse, we need to have like a great deal of force, or like you mentioned, like or uh, we have the fastest, like what is the name? I can't forget. Time
Speed
of
jumpers.
yeah. So how exactly do you like program like the force side of force velocity curve and the velocity side of like force velocity curve? How do you manage this?
Um, well, in terms of the force velocity curve, I think we need to understand what the muscle fascicles and what the tendons are going through in fast stretch shortening cycles. So even though in a takeoff you would be able to observe, let's look at the knee joint, you would see while getting into the takeoff, you would see that the knee reaches smaller knee flexion angles. So that would be what we would term the eccentric phase. And then from there on, it would move into a concentric phase. But what actually occurs is that the muscle fascicles are changing either none, so they're either working isometrically or they're working slowly concentrically through the whole stretch shortening cycle. So when we see that there's a larger knee flexion angle in the first phase at touchdown, it's mainly because the tendons are elongating. We're building elastic energy into our tendons. So I would focus on being extremely strong isometrically, perhaps quasi eccentrically, depending on we know the mechanics of some muscles. So what I just mentioned here about the muscle fascicles working isometrically or slowly concentric. That's true for the soleus or the gastrocnemius. We haven't measured on all muscles, and it probably also depends on how long and strong the tendon that it's attached to. So we know that's the mechanics of the triceps surae, but we're not sure it's the same for the quads and so on. But it sounds like a plausible explanation. So I would focus on being extremely strong, but not maximally strong, like rate of force development strong. So we have a relatively short time to produce force. So I would try to maximize that in an isometric or slow concentric movement. So even though it looks like we're moving with large velocities, like typically in a high jump, you would see an approach speed up to 8 meters per second, but that's in a horizontal direction. If we look at the change in velocity in a vertical direction, it's typically from 0 meters per second or minus 0.5, and then the best jumpers would reach around 4.5 meters per second vertically. So the velocity is significantly lower there. So I'm not a big fan of necessarily surfing the curve in terms of force velocity. Also because the force velocity curve, the classic curve, is based on a single muscle, and it's a pure concentric movement. And most of our sport-specific movements are preceded by an eccentric phase, or a phase where we can actually load it. So that will look significantly different. And I've also seen a lot of illustrations where we place different exercises on the force velocity curve, where you would place, let's place a 1 RM max squat movement at the strength at the force side, and a hurdle hop or sprinting at the velocity side. But looking at sprinting, peak force is significantly larger when doing sprinting, when we are measuring vertical forces going up to 5, sometimes perhaps even 6 times body weight, very briefly, but very, very high forces. So that's in the vertical direction. And then horizontally, we have high velocities. So when we're sprinting, we're just producing enormous amounts of force, higher than we could ever see in any weight room exercise. So we can't really place stretch shortening cycle on a force velocity curve. So I do have my reservations in terms of surfing the curve. Definitely pro maximizing intent in whatever exercise you're doing, as long as the quality is good. So if you're doing sub maximally loaded squats, I would just focus on maximizing intent concentrically.
Nice. So, since like you mentioned, is nothing's gonna be able to compare with sprinting. So, uh, let's say if I'm training like no matter it's like basketball player or like sorry, a football player, why don't we just train sprinting, or like just train sprinting or change the direction movements for their performance? And weight room is more like a tendon health or like tissue health, that kind of stuff. Am I understanding this
Yeah.
right?
No, I agree, and it's also it's dependent on your level as an athlete and your training history as well, because you could place the developmental athlete in the weight room doing conventional deep heavy squats, and they would improve in their sprinting as well. So the spectrum of exercises where they can get a direct training transfer is relatively wide. But as your level increases, so does the spectrum of exercises where you can expect a direct transfer. And at some point, we can't really expect a direct transfer anymore. And then we would mainly focus on injury resilience, so tendon health, but also perhaps tendon stiffness. So we would go for the morphological changes. We could still use the weight room to stimulate the neural system in a manner where we have very low impact. So in basketball, you also have a lot of impacts in terms of jumping and change of directions and so on. And obviously, if you want to improve that ability in the context of basketball, play basketball. It could be, I mean, it could be difficult to change to control the volume and intensity and perhaps also if you have some technical things you want to alter. But I would definitely focus on changing on training those quality in that context, because the ability to accelerate or sprint in a closed skill sport is just very different from an open skill sport. So it's a relatively easy task in a closed skill sport. Well, it's not necessarily easy, but we understand the model of how we run, how we sprint fast. But the optimal model for a basketball athlete would be a robust model. So they need to understand, when do I need to apply this motor pattern in this specific context, because it's so contextual what's right. It doesn't matter how high you jump if you try to jump high in the wrong context. Sometimes you just need to be really quick at jumping up to a certain height, or you need to be really skilled at in your perception of what the opponent is doing and so on. So it's just much more complex, much more multifactorial what determines performance in an open skill sport like basketball. So we can still, I still think it makes sense to understand what we would term the optimal model in closed skill sports. So they know what the optimal is, and then sometimes, depending on context, they can't perform the optimal, but they can get pretty close to it. I don't know if that answered your question.
Yeah, of course. I love that. I love that one.
Right.
So that brings me to the next question. I'm sorry I'm gonna jump out the list I sent it to you, but your answer is just
No worries.
fascinating. So that brings me to like kind of want to ask about like your thoughts on long-term athletic development. So like the example you just mentioned, like for like younger athletes or like not not that elite level athletes, we mostly train them to like squat heavier, like deep squat, so they can increase their like all sorts of like jumping, running. But there's gonna be a point that squatting heavy not gonna be able to help them. And at
Yeah.
the early age of like training athlete or like maybe junior high or like high school athlete, at that early of age, training them to like squat heavy, is it for me personally, I don't train my athlete to like squat, deep squat or like bad squat that heavy, but I train movement. But what are your thoughts on like long-term athletic development?
Well, I think it definitely makes sense. As coaches, we have different trumps on our hand. We know very effective training modalities that they would, if they're able to tolerate it, that would increase their performance. But in terms of long-term athletic development, we want to throw those trumps as late as possible. So if we are able to experience progress with these athletes without putting these trumps, without exposing them to high intensity plyometrics, systematic plyometrics anyway, super maximal strength, very joint specific movements in terms of being very specific to the movement they need to improve. Because typically when we increase specificity, we also increase force and the load going through their backs. So I definitely agree. Doing these more rudimentary exercises, it could be deadlift, it could be squat, and so on, would hopefully stimulate their it could be their lower backs to be able to tolerate the heavier loads we need to place on them later on. But I would definitely wait as long as possible on exposing them to these very, very high intensity, but also very effective training measures as long as they're progressing. because if we expose them, let's say you have a very talented athlete being being a candidate for some of the world junior championships in athletics or something similar, then we could expose them to all these high intensity training modalities. And if they could tolerate it, they would perform really, really well at those junior championships. So what, and maybe they even end up winning. So after that, what are we able to do? What can we expose them to continue that performance optimization? Not a lot, because we all already exposed them to these high intensity training modalities. So in terms of motivation, also being able to progress continuously, I would try to expose them as late as possible. Yeah.
Is it the same with like max intent sprinting or like max intent jumping? Instead of like we should just expose them to like rudimentary like skill or like or or try to like minimize their chances to expose it to them and that kind of build the base and as time goes longer we expose them more about like maximum intent sprinting.
Well, I mean, to some extent, it's quite there's some sort of auto regulation here, because if you're 14 years old, there's a certain limit of how fast you can actually run, and the motor pattern is very dependent on velocity. So you could start, you could choose to go, let's just go 80% or 90% all the time, but that will be a slightly different motor pattern than full intensity sprinting. So in general, I think we as humans are robust. We just need to be considerate about the volume and the intensity we expose our athletes to, because young athletes can easily deal with high intensity. Like that's what occurs when they're doing the long jump or sprinting, jumping down from a tree and so on. We can't even get close to replicating those forces in the weight room. So we can tolerate that, but we just shouldn't expose them systematically to those very, very high intensity. I mean, they can easily tolerate that once or twice, maybe 3 times a week, but they definitely can't. We can't expose them like every day.
Nice,
Yeah.
nice, nice. So uh I'm sorry I jumped out the list. I'm kind of want to like go. I'm gonna go back to it. So,
Okay.
in your Instagram, you post like hurdle jump. So, what I noticed that there's a tons of like discussion about like should we train our athlete like hurdle jump and how high should we train them? So, what are your thoughts on like these kind of like discussion? So, in what situation you're gonna put on like hurdle jump and how high?
That's a good question, because the height of the hurdle does not equal the height of the center of mass. Well, yeah, it does equal to some extent the height of center of mass, but not how much you've actually. It does not equal your vertical takeoff velocity, and we actually want to optimize vertical takeoff velocity in the hurdle hops, because let's say we're jumping on a 99 centimeters hurdle. That's the second highest, and we put 2 different athletes through that. One athlete not having to can perform these hurdle hops without a large degree of hip flexion, like tucking your knees up, while the other needs to tuck their knees up maximally to clear the hurdle. So I would at any time I would prefer the ability to produce crazy amount of force on the ground, thus reaching a high vertical takeoff velocity. So you don't need to see a high degree of hip flexion to clear the hurdle. So I would see, are you altering your mechanics in order to clear the hurdle? Or are you actually increasing contact time because you need more time to create the necessary impulse? Then I would lower the hurdle. So it's actually quite contextual. I would definitely not just focus on maximizing hurdle height, but I would try to optimize technique in the hurdles in order to still have reasonable contact times and then still be able to clear the hurdle with a decent technique.
Nice, nice. So, you mentioned a lot of times about like vertical takeoff velocity, and we discussed about like jumpers previously. But what if I want to like increase my vertical takeoff velocity for like a basketball player, for volleyball player? Is there a way to like or is there easier way to like understand it for like team sport player, team sport athlete, sorry.
Well, the physics are obviously the same. That doesn't matter of the context, but often, like in basketball, you'd see a 2 foot takeoff. Often, you would not have the ability to have a large approach speed. So the model I use to understand vertical displacement of center of mass in high jump is that we're using the horizontal momentum from the approach to build up elastic energy in our tendons. So if we're able to produce high amounts of rate of force development, then we'll decelerate this horizontal momentum very rigorously, and we will build up a lot of elastic energy. And this elastic energy will release in the concentric movement. So high jumpers or jumpers with an approach need to be conversion specialists. They need to convert a large horizontal momentum, and they use that to build up elastic energy to convert that into a vertical momentum. And sometimes in the context of basketball, you don't have that opportunity to build large horizontal momentum. So you actually need to build momentum instead of converting a large horizontal momentum. So it's a different quality. If you want to be really skilled at a standing jump or a jump where you don't have a lot of horizontal momentum prior, then you want to look at exercises like they're doing in weightlifting, because weightlifters are really, really skilled in counter movement jumps and so on. So really skilled at building momentum instead of converting momentum. And you need what is optimal tendon stiffness is very different in these two contexts. So you can be very, very skilled in one context, could be where you need to convert the horizontal momentum into a vertical. That would demand very, very high tendon stiffness, high reactive stiffness. Same goes for sprinting. If you need to be an expert in building momentum concentrically, typically, maybe with a slight counter movement move, then it's a different quality. And in basketball, you probably need to be skilled in both. And you also need to be skilled in masking movements. If you're an offensive player. So it's just very contextual what's optimal in complex sports. And they need to be robust, skilled in a lot of these types of movements, and they need to be experts in the decision making of which movement should I choose now.
Love that one. So, uh, I'm gonna ask you a last question before I let you go, okay?
Okay, no worries.
So, I'm gonna want Nordic hamstring curl for like sprinters. What are your thoughts on like displacing these kind of exercise for sprinter and thoughts on like isometric hamstring training for also for like preventing hamstring injury?
Well, I lean quite a lot towards the research on this area. So performing isometrics, it could be typically isometric holds at long muscle fascicles is definitely protective against muscle strains. So if you suffer from muscle strains as a sprinter, then obviously you need to consider, am I sprinting enough? Because there's somewhat of a hormetic what's the writer? There's somewhat of a hormetic uh, combination between uh, the amount of sprinting, intensity of sprinting, and the risk of injury. So we need to reach somewhat of a sweet spot. If we expose ourselves too little to sprinting, then we won't be vaccinated towards muscle injuries. So sprinting is actually the best modality, training modality you can do to protect yourself from getting injured. But then on the other side, you can also do too much sprinting or too high intensity sprinting. So you need to figure out what's the sweet spot. And then we need to figure out, okay, perhaps I can tolerate sprinting maximally twice a week, maybe even 3 times. Do I still want to try and expose my hamstrings quasi-isometrically, perhaps eccentrically, to increase muscle resilience? Well, yeah, perhaps. And in that instance, slow eccentrics, slow supramaximal eccentrics, or heavy isometrics at long muscle fascicles are just a great choice. But all in all, we need to consider it's basically a cost benefit, because all training has a certain costs in terms of recovery, sometimes also in terms of time. We need to figure out, if we have a limited amount of time, what's the optimal to do right now, but definitely in terms of recovery. So we need to figure out if we're perhaps doing something in the weight room that's too specific, that would potentially cannibalize on what we're doing on court. If it's too similar, then they will put a tax on the same recovery systems. It could be tendons, it could be muscles for that matter. So it's a balancing act somehow, and we need to consider that also in terms of periodization. If we don't have a lot of high intensity sprinting, then maybe we actually do want to expose athletes to super maximal eccentrics in the weight room in order to protect them and prepare them for their high intensity sprinting.
Nice, nice. I love that. I'm sorry I didn't follow the list I sent it to you. Your answer is
Don't worry.
just fascinating. I really,
Well, thank you very much.
truly enjoyed talking to you.
Yeah, likewise. I mean, very nice meeting you, and again, thank you for inviting me to your podcast. It's an honor.
Of course, of course, of course. So, for those who are interested in what we're talking about today, where can they reach out to you?
Well, typically people reach out to me on Instagram. My handle is VIDENFORM, or they can just search on my name, which is Thomas Cortebeek.
Love that. Love that.